Hello and good morning, everybody. We are about to start our user forum. This is a bit different to the other events from yesterday because we're doing a hybrid session. So we do have some remote participants as well. Great. So we're just waiting for people to finish assembling in the room and then we'll get started. Today we have a few people from our ARCHER2 team that are going to talk about various aspects of the service. And then at the end, we hope to have a bit of a lively discussion, get views from you, any input. A little about myself. I'm Josephine Beach-Grant. I head up the user support team for ARCHER2, our EPCC, and our other user services there. So without further ado, I think we should start. So I'm pleased to introduce James Richings from the ARCHER2 team. He's going to be giving us a bit more of an update on the new GPUs that are in the service. Thanks, James.
So good morning, everyone. I'm just going to give this morning a brief overview of what the GPU component of ARCHER2 now is. A little bit of detail on what the hardware is in the nodes, how you can use them and get access to them right now. Some thoughts and discussions for the coffee break. I was going to follow on really from what we were discussing yesterday and the sort of information we need to start to understand about what communities are looking at in terms of GPU so that we can know what we need to support in future and how best to support you. And then a few upcoming opportunities to get more experience skills and look at development work in this direction. So it's a small resource. It's only 4 nodes and 16 GPUs. It's designed for development and testing. It's not production and science we're expected to run on this. It's integrated into ARCHER2 directly, so there's no separate login nodes. You log into the main system and submit jobs. It's available to ARCHER2 users with a positive budget, and there's no charge for this. So please, if you have time, get on and use it and want to understand your experiences with the system. There's documentation that we've gone through to try and give you a lot of detail around the configuration of these nodes. And if there are gaps, please let us know. This we'd like to see. We're happy to engage on that. So what are these nodes? So these are, they have 4 GPUs per node, very similar to what Mark was saying yesterday. It's MI210s. So they are of this sort of similar era of the MI250Xs that Frontier has, but some slight differences. Communication between the GPUs directly is quite fast, but the connection between different nodes is a little bit slower. So there's a slight hierarchy there. And you can test this yourself, and it's a key feature of these sort of types of nodes and how you get performance using Rock and Bandit test that's on the system now. Okay, so if you're a new user who've not played around with this technology before, that's a nice place to start, is to get an understanding of what performance considerations might be. Compiling. The programming environment with GPU support is available on the login nodes for ARCHER2, on the GPU compute nodes, and on the serial nodes. There's a variety of different offload methods and compilers. These are all in the documentation, but there's several programming environments and then a level of compiler support, offload support. We tried to detail that and test it. I know Arno did a lot of work, and I think Douglas from the COE did some as well. Obviously, if there's gaps or issues with that, please let us know. But the idea is we want to cover as much of the space as possible so that you guys can test. In terms of scheduler and configuration, so there's basically 2 queues for this. There's an exclusive and a shared. The exclusive queue lets you get access to a whole, up to 2 whole nodes, and you get all the GPUs. Or the shared access allows you to get access to up to 2 GPUs in various combinations. So the point of that is we want to provide, because it's a limited resource, as much capacity for people to test and use, but also the ability to get a dedicated node or 2 and look at what performance could look like on something like this. This is obviously, if this needs reviewing, I think that could be a discussion, but at the moment that's how the system's set up. So this is kind of, I wanted to generate a bit of conversation around, in the discussion around what the landscape looks like for supporting and moving to GPU-based codes. So there's a balance here, and we had a very nice talk from Chris Maynard earlier in the week at EPCC, and I was originally thinking it's for performance for supportability, but he also put this idea of productivity. How do you abstract your science developers from the complications of parallel programming? That's difficult, and can you? So there's 3 things here really. It's We want to be portable because we don't know what hardware we'll be running on. We want to be performant because we want to get good time to science, but we need to be productive because the aim of here is to put new science into our codes a lot of the time. It isn't always about the developers. We need our users to be ready to use these types of machines, and what level of knowledge do they need to be able to run effectively systems. And what support do your communities need now, and how can we use the fact we have GPUs in ARCHER2 to help you? And there's a few activities I'll come on to that are already underway. I looked at this diagram and thought there's a bit missing, and it's kind of there's a forefront looming over this, and I think we kind of discussed that yesterday, because this diagram kind of comes out of the ETP project a little bit in terms of their investment in C++, but this is keenly on our minds, and how we support this community that heavily uses Fortran effectively is something we need to discuss also. So to go into a little bit more detail, but not too much, this diagram of sort of the level of support and the range of hardware for the future was presented in a paper at Supercomputing. And you kind of have three classifications of, so you either have kernel level models, you either have something sort of directive approach, or you try and get something portable. But the problem is that there's not good coverage in any place. You're missing aspects in most areas. And kind of the questions to the coffee break, what I thought might be interesting to discuss would be, what directions are your communities looking at? I know the larger communities are probably already thinking about this, but there's a lot of different types of users on ARCHER2, so how do we support everyone? What combinations of hardware software have you had a chance to test? So you may well have tried CUDA or NVIDIA in the past, but AMD is now offering on ARCHER2 that gives a bit more breadth to your access. What works and what doesn't work for your scientific codes? We had a discussion yesterday around FFT being appropriate to run on GPUs, and that needs clarity. If there's multiple communities that have the same problem, then that's something we can discuss as a group. If you've not started looking at GPU porting, is there a barrier there? Is there some support you need? Please help us know how you can start this process. And is it clear for your community what route to GPU enabled HPC is right for you, and have you got a plan? So a couple of things that are upcoming. We've got 2 training events. The first one being organized by the Center of Excellence, and next week, an overview of the ARCHER2 GPU development platform, and that's running online. I think Harvey and Douglas are running that one. And then in about a month or so time, we are running an introduction to GPU program with HIP, and that will be me and Juan and someone else helping that program, and that's looking at just an initial development using the HIP API. And importantly, and I think this has been mentioned yesterday, there is the open call for the GPU EPCC program, and we expect that to have at least a couple of calls this year. The deadline is on the 19th of this month, and it allows you to get some effort to start looking at porting projects. That's kind of all from me. So there's access now. Please use it and let us know and raise the issues you have with it, because it's something we want to engage with you on. There's shared access and there's documentation that's in place, and there's open ability to get some training and to get some development time. That's all from me.
So as James mentioned, there will be time at the end. We're going to do a wider discussion, picking up on any of the points raised in the talks. But we will move on now to Kevin Stratford, who's going to talk about the capability days, which is coming up soon.
Right, so thank you, Joan. Okay, so this capability days, I've always kind of been in my head that this was Andy Turner's idea. So we'll give him the credit for that. Andy would have talked about this, was he here, but he couldn't be here today. So I'm here instead. Okay, so capability days, we hope will be days plural. So this will be an ongoing thing, we hope. But the first capability day singular is next Thursday in my mind. It's actually 9 o'clock in the morning to 9 o'clock in the morning on Friday, which is 24-hour period. So what's this about? So we use the term capability in high performance computing usually to refer to jobs that are sufficiently large that they cannot be undertaken on any other resource. So we were looking for mechanisms to try and encourage people to use the machine at this kind of scale. So we've got a very big machine, expensive, high-speed network. So we would like to encourage, ultimately, production work at scale. So that's the main driver, and of course, if this can be done, one hopes in the end we enhance outputs in terms of world-leading results. So we have been aware over the lifetime of the service so far that there have been barriers to using a machine at scale. For the first year or so, there were some technological issues, and running jobs at scale was, definitely a risk in terms of having network instabilities and failures and so forth. But our feeling is that since the upgrade that took place last May, the situation is much more robust, much more stable. In terms of why people aren't doing this so far, there's also, it should be said, there's probably a degree of apprehension amongst users to doing this kind of thing. If you want to press submit on a job that is going to blow, 10,000 C units of allocation in a couple of hours, you need to be confident that something sensible is going to happen. So what we'd like to do here is to provide an opportunity, a risk-free opportunity, if you like, for people to have a go at running at scale without charge, effectively, and to give people a chance to do that. There's also a potential issue if an individual submits a large job. Of course, the machine has to drain to allow that job to start, and so there is an overhead in that, in the machine being idle. So it's helpful from our point of view if we can bundle lots of these jobs together in one go. That reduces the overhead of draining the machine. Okay, so this is the idea. We're going to make this 24-hour period available for you to have a go at running large jobs. So the name of the game is this. We've reserved actually 17 full cabinets with the idea that the largest job will be 16 cabinets or 4,096 nodes. The remainder of the machine will stay running its normal complement of work, but that reservation will be set aside for these capability jobs over 24 hours. Anybody with a positive budget can queue a job. The queue, as I said, the reservation will last 24 hours with a few caveats in place. So, for example, if there's no work in the queue or being queued for some period, then we'll probably just shut it down and return this reservation to running the normal run of jobs. But hopefully, I'm hopeful. I had a look the other day. There were certainly some jobs queued already, so we're hopeful that there'll be enough interest to fill the whole 24-hour period. Okay, so there's some limits. There's a minimum job size. So the minimum job you are able to queue will be a requirement of 512 nodes. We have no way of enforcing the fact that you use less than that in a given job step or S-run, so we're relying on people to be sensible here, and we expect all job steps to use the full allocation. If we detect evidence of backsliding on that, we will reserve the right to remove such jobs. The maximum wall time for an individual job will be 3 hours. And you just need to submit to this capability day QoS. That's everything else is as normal, with a budget that has positive balance. Okay, so if you want to get into this game, we have there's a page in the user documentation which has these tips. I think might be worth just thinking about one or two of them here. Our experience broadly is in terms of the network transport layer, we should be using OFI and not UCX. Because UCX is somewhere, certainly at the very largest scale, we're still seeing a few problems with UCX. There's obviously things in terms of parallel design that you need to think about. Maybe okay, maybe a bit late at this stage, but if you have options to do different things, you may need some caution, such as one may wish to start avoiding a lot of all-to-all collectives and things like this if you're running at scale. Alternatively, you may have to think a bit hard about what your problem size is or how long you're going to run to fit in the queue. Every good benchmark should probably consider I/O, so there's various things to consider there, and you need to think about this beforehand to make sure everything is as it should be. Our experience is that, certainly my experience, is that if you're trying, for example, MPIO collective output to a single file, you're certainly going to hit limits in terms of how far this is going to scale. So ultimately, you might have to think about starting decomposing your output and things like this. You need to watch out, particularly at scale, for any serial overheads. This may include things like MPI startup at the barest level. If you're running on 500,000 MPI processors, if you want to do things like Python, there are methods to try and mitigate overheads there as well, which you may want to think about. How am I doing for time? Practical considerations. So you need a bit of a plan to, you want to think about what you're trying to get at in submitting jobs here. You need to think about testing job scripts before submitting them on perhaps a smaller job. So if you think about testing, you're scaling up to 256 or 512 nodes in that area. Should be able to give you a handle on what scaling you might expect as you go into the larger node counts. So you want to think about combining work or different options, different runs at fixed node count in the single SBatch submission. That's usually what I do if I'm playing this Again, can help, and it helps you in ways that you know you can do your comparison of what you've got, and you've got the same allocation of nodes in all cases. So that's things like that can be a help. You're isolating the fact that you're not running on different sets of nodes every time. If you're doing I/O, we are suggesting using the solid state Scratch file system, which I think Kieran is going to say something about next. So all projects, in principle, are allowed access to this. So if you think your project doesn't have access to this at the moment, please just email service desk help. If you don't know what if you have or you haven't, you can just have a look in that directory there for your project. That should tell you. And we're encouraging people to submit jobs ahead of time. There will be obviously an opportunity to react on the day, but we don't know in advance how busy this is going to be, so I don't know what scope there may be to get new jobs in on the day. That's something we'll have to think about. Okay, so this is just the headlines. I think we're having questions later, are we? Okay, right, okay. Please have a go, and depending on how things go, I think this is a positive development in trying to encourage people to start thinking about, regular production work at scale.
Yeah, like I said, there will be opportunity at the end to raise any points, and we're all around anyway for the rest of the day, and people remotely can add to the chat. So our next talk today will be by Kieran Leach. There we go. And Kieran's one of our system support team members, and so he's going to tell us about the new file system we've made available to users.
Good morning, everyone. As we said, I'm here to talk to you today about the recently deployed solid-state storage for Scratch file system, and I'll start that now. So a little bit of background on this. This is a ClusterStor E1000F Gloucester appliance from HPE. It's broadly speaking the same technology as the work file systems you're used to working with. It's a bit smaller, it's 1.1 petabytes instead of approximately 3 petabytes as each of the other work file systems are. It's all NVMe, so the data is stored across 10 servers on a total of 240 6.4 terabyte disks, and the metadata is stored on 24 1.6 terabyte disks. There's a lot of bandwidth here. You've got a total of 8,400 gigabits per second to this file system, including the metadata. You can really push to this thing. Now, the quotas are not set up normally, and this is not available to everyone by default. If you would like access, please contact the service desk by the usual route. We do expect, in a lot of cases, increased performance for users from this file system. However, it's not universal. You'll see there's a caveat there that if you use MPI-IO approaches, including parallel HDF5 and parallel NetCDF, you're unlikely to see an improvement. But it may be worth using anyway for the space. There are no traditional quotas in place on the Scratch file system. You're allowed to use as much as you want up to the per project limit of 250 terabytes. That is to prevent one group from spawning a petabyte's worth of data. Not that you would, I'm sure. This is applied as a blanket quota across a project. We won't be individually managing that at any stage unless we decide to change it for everyone at some point in the future. So when you're set up, the project will have a 250 terabyte quota, and so will each and every other project. There's no ability for PIs to manage this. It's just a universal value. And as I say, we may review this in future if it's necessary. We'll just see how people get on. To give you an idea of what this means, though, projects typically receive on the order of 500 gigabytes to 5 terabytes of space for their project. That's the little gray bar on the left there. Consortia typically will use something on the order of 220 terabytes to 200 terabytes. That's the large orange bar. 250 terabytes is larger than you would expect anyone to have on the work file systems, regardless of their size. So there is ability for, in the shorter term, within jobs, to really scale up the amount of data you're looking at. However, we're going to delete it. It's the first time I've ever stood up and said, we're going to delete user data. All files older than 28 days are deleted automatically. This process runs at 9:15 every morning. This ensures capacity is retained for all users, because this is not, this is a storage system, but it's not for storage. It's for actively processed work. And this is it's a true Scratch file system. Deletion is based on the last access time. So if you know your Linux file attributes, there is access, create, and modify. We base it on the last access time. So files that are in active use shouldn't be impacted. If you've run a job against it recently, any file that has had a job look at it, has accessed it, that file should not be deleted. As I said, this is triggered every 24 hours, and you can identify candidate files for deletion using the find command there. I won't pretend we're doing anything more than advanced than that when we're deleting it. That's a find command as well. It turns out that sometimes the oldies are the goodies. So that's a quick summary there. I think I've covered everything though, so let's move on. Thank you.
Thank you, Kieran. So our last presenter, before we move on to the general discussion today, is Juan Herrera, Rodriguez Herrera. I've been practicing specially, sorry. He's going to be talking about the ARCHER2 training, and then once we've heard from Juan, we're going to have the general discussion.
Good morning, everyone. Thanks, Joe, for the introduction. So, yeah, this is what I plan to cover in this 5-10 minutes, because I would like to give more time for discussion, questions. One introduction of what we do at ARCHER2 training. Present, that is a typo because the program that I will, the draft is from this year and next year. You can notice that, copy paste. And the questions discussion, that would be like the last section of this ARCHER2 user forum. So the introduction is as part of the ARCHER2 service, we have a training section that delivers more than 60 days of interactive face-to-face and online training that could be of courses, webinars, etc. So the idea is we have a course catalog that covers our users' needs. We have a self-service courses that the list is there and is growing each year. The courses that we have so far is MPI, OpenMP, GrowMax and CP2K, and Introduction to HPC. All past course material and recordings are available on the ARCHER2 website. It's not mentioned there, but all courses are free for academics. So in case that you see a course that is interesting, please join the course. And we update the course catalog every year based on feedback. Feedback from previous attendees of the courses that we deliver. The ARCHER2 training forum, that is like this event. Every year we do it differently. Like last year was online as well. Previous time was like a short. So and the ARCHER2 training panel is composed of international experts in HPC, and this is where also we get some feedback. So this is the ARCHER2 training program. Rather than listing all the courses, what I have done is a bit of, I'm listing the topics. So the topics that we cover is we have 2 courses on software carpentry, 2 courses in data carpentry, and we will have 3 courses in HPC carpentry. We also cover MPI. We have an introduction and advanced course. Same with the OpenMP. We have also 2 courses on C++. We have 2 courses in Fortran. One is introductory, and other is more, let's say, it's the follow-on. Is the intermediate Fortran. Also, we have some section more dedicated to data science. That is introduction to data science and machine learning. We may add a course on AI. We have also another course on Python that is more focused on data analysis and visualization, data analysis using pandas, and visualization using, if I remember right, Plot9 and Matplotlib. As James introduced before, we have GPUs, so we will have some training on GPUs. Also, well, other courses like containers, efficient parallel I/O, reframe, that will be a new course this year. When I talk about the year, it means like May 2024, April 2025. Also another course on single node optimization. We have also that is a valid training delivered by HPE that normally talks about the Cray compiler suite, profilers, techniques to make the code more efficient. An example is next week we will have a HPE course on GPUs, and webinars that are general topics. Is not. So this is the last slide from me. The regarding questions discussion is having this table. What topics would you add, remove, or keep, or do you think that are more important, or do you think that we should have more courses, less courses, etc.? In case that, because we will have now some discussion until 10, but in case that for some reason, yeah, you don't have the chance, or you want like to have a quick chat with me, like over a coffee, I'll be around until 4 p.m. So please let me know. I'm more than happy to chat. Also, you can find my email somewhere on the internet. So just contact me. I'm really happy. Yeah, via email, chat, call, whatever. Okay, the other 2 questions is that if there any course that you or your consortium will be interested in, particularly, yeah, we will be more happy to talk to you and trying to deliver the course on appropriate dates, time, etc. And also this is well. On the third question is we have a list of service courses. Would you like to have another course in that list? And a question that is not listed there, that this is also open to you in case that you have an idea of a webinar that you want to present. Please contact me and we can find a suitable time. And also in case that, for instance, you have, because we would like also to cover research software packages. So in case that you are working in a software package and you want to deliver either a webinar or a one-day course, we will be more happy to help you with the logistics in case of course registrations, access to the machine, the platform, this online platform that is Blackboard Collaborate, and that we are open to discuss options regarding training. Another example is, for instance, in April we have a course on Scompa 3D that is we did some collaboration to organize the course together. So yeah, if you have something that you want to deliver, this is open to you. And I stop talking, and because I would like to hear your point of view, discussion, and I think now it's okay. Stop talking. Thank you.